Iron is this. The symbol is Fe. Its name is got, as long as you get that there's a difference between the name and the symbol. You know the name was got from a Latin what? Latin name, isn't it? Now this Latin name is what we call ferrum. Ferrum. This is double R. Ferrum. That is the Latin name for iron. Now here we shall not mind of the Latin name. We shall only mind of the English name, iron. Okay? But if they ask for the symbol, you write for us Fe. Then iodine is written as that. The symbol is I. That is all. You find others like mercury. We shall get to know their symbols later on. Who knows the symbol of mercury? Mercury, who knows the symbol? Mercury. The symbol of mercury. Yes.
MR.
MR. MR is not a symbol of mercury. Thank you for the trial. So a symbol for mercury is capital H, small g. It is got from the Latin name. Okay. So we shall give others, even silver, you find the silver is Ag. Silver is Ag because you can't write silver as Si or Sl. Other symbols are there. It is got from a Latin name. Ag is argentum, that is the name. So as many others, but the most important ones are the first 20 elements of the periodic table. Once you get to know them and their symbols, chemistry will be a little easier for us. Now, are we in yes.
What about the symbol for pyrethrum?
What?
For
pyrethrum is a
yes.
metal. Huh?
No.
It is?
I'm saying Ratherium.
La?
Ratherium.
Craterium?
No.
Maybe.
It's rhodium.
Rhodium or rubidium?
Rhodium.
Hey, you are forming names from your name.
No.
Which element is called rhodium?
I don't know.
Because there are many elements here.
Teacher, it's here.
RB is rubidium, not rhodium.
Teacher, the one number 44.
Number 44.
They are very small.
Widen them.
44. Eh. Okay, because somebody also asked me for that whatever one day is called RU and told me there's a symbol called Ruthium in the chemistry. Because she was called Ruth and she said the same word. So these ones in the middle, mostly they are called the transition metals. All these elements you see here, they are metals and non-metals. When you study deep this periodic table, you will come and you will find out that this one that are on in 1 and 2, 3, that's where metals stop. Non-metals take over from 4, 5, 6 up to 8. That's where you find non-metals. That is where I want to show you. Now, all these in the middle here, you see this gap? All this gap from here up to here, we have elements that are called transition elements. Transition means they have a certain color in them. That's why you find iron has a different color, cobalt, nickel, copper, zinc, all these have different colors. While all these that are here, 1 and 2, they are white. You don't find any color with them. If you find a metal, it is gray in color. That is all. So all salts, okay, actually all metals of these whatever, of these, all these metals of 1 and 2, they have one general color. But these ones, each metal here has its own definite color. Those ones that are here. Then these ones, they are also part of this table, but they're always down here. The number continues just. So these ones are attached below here. And that's how the name comes. So since you have known, now these questions you can answer. The first question says, what is an element? What is an element? According to who? Who is there? We have defined elements. Have you got the definition of the word element? Yes? Do you have an element definition? Yes? Joshua? Joshua? Joshua?
Yes.
You have just come in.
Yeah.
Okay, you have found us. I don't know, but the video is there. You will watch, and we are just going to upload it.
Yeah,
So what you do, download and watch it, okay?
Yes.
It will help you. You have found us in the right place. We were just trying to look for the word an element. What is an element?
Teacher,
Yes.
I have tried to watch videos about that periodic table, but there are some people who don't normally explain it properly. But others, you get them.
Yeah.
But whenever you watch this table is two columns, which is down.
This one down. Yeah.
Yeah, that one, the downer one. It is said to also be put here up.
Up where? Here?
Right here.
Right where? Where? Up where? Up this side?
Yeah. Huh? Yeah, no, here, to join this gap in the middle.
This one? This one
this
up here?
This,
huh?
Yeah.
This is, actually, when you look at this, you look at these metals, there is 57. Where is 57? 57 is this 54, 55, 56. Now here you see 57 to 71. Have you seen it?
Yes.
That's where the first table should be. From here, 57 to 71. The first, all these elements up here must be fixed there. And the name is called lanthanides. Have you seen the name?
Lanthanides.
All these are lanthanides. The one you look at them down here. Okay?
Yes.
Then you check 80 to 103. Where is it? It is just below that one. It is called the actinides. And they are supposed to be fixed there where that the table is.
Yes.
Now, have you got it clearly?
Yeah.
So for us at this level of education, we are not minding about the whole of it. The most important ones are the first 20 elements, first 20. Since the head, you cannot accommodate all of them, they thought twice that they say that this level, called O level, we can only first get to know the first 20 elements and how they behave. The rest will come when you advance in the chemistry, that is A level. Okay?
Yes.
Yeah, they will give you the chemistry of those elements when you reach now A level. But the chemistry we talk about is now these first 20 elements, the first 20 from here You go to this up to where 20 is. Have you seen 20?
Yes.
The last element is calcium.
Yeah.
Though there are some elements or ions or elements they pick from here to study about. An example is copper, zinc, lead is here in group 4. Here we have lead, we have, this is what AU is gold. Most of them are there. Okay, we shall also pick some few to add on these 20 elements, but the first 20 must be known by you yourself. Okay.
Okay.
Yeah.
Good. Okay, back to our main point of discussion, the element. So from our definition is, an element is a substance, is a pure substance. We looked at a pure substance. Someone defined for us a pure substance. So when you're defining this element, you say it is a pure substance which cannot be split into simpler substances by any chemical means. By any chemical means. When you talk about chemistry and you are trying to split some things, we don't split them using the hand. Okay? We separate those substances by chemical means. So if they talk about splitting things in the chemistry, you don't use an axe. Huh? Or you bring a panga, you want to split an element like this one, as small as it is. We don't split them with those things. We bring chemicals to distinguish between the elements present. Is it clear?
Yes.
So if you cannot split anything, if you cannot split it by any chemical means into simpler substances, then that is a pure state of an element. So it's called an element. Have we got the definition of the element?
Yes.
Good. Now, in the table, do you know the names of any common elements? The common elements are the first 20 I gave you. Do you know the name?
Yeah.
Good. And now among these, in the 20, which one do you have in the 20 elements? Iron, carbon, sulfur, and oxygen. Which ones are there in the first 20?
Oxygen, carbon.
Only?
I can't see.
Check properly. In the first 20 elements, we have carbon and oxygen only.
Also this one.
What about sulfur?
Yeah, sulfur.
Sulfur is there. It is only iron that is here, mixed up here in the transitional elements. So it is somewhere here. It's 26. Is it clear now?
Yes.
Yeah.
Good. So we looked at the way of determining purity of a substance. That is the way you determine it. You look for its boiling and melting point. If you want to look for the melting point of a substance, what you do is get ice of distilled water. Use distilled water and then tap water. Then try to crush both of them and you insert them in a thermometer and time in a plastic cup. We looked at materials. Why do they use plastic cups? Why do they prefer plastic cups to a glass cup or a metallic cup or any other cup?
So can I try?
Yes, try.
I think because when mixing chemicals, some of them boil.
Some of them boil. Okay, in this
Make
state,
the
they are
cup
using,
cold.
yeah, it's true. What you have said is true. Now, they are saying here, ice made from distilled water ice crushed, made from tap water, thermometer, clock, and a plastic cup. Now, the reasoning here is plastics don't lose heat as fast as the other cups. Is it clear?
Yes.
Yes.
You find a plastic cup and the other metallic cups. This plastic can keep the temperature for some good time, other than a metallic cup that withdraws the heat and transfer it to another substance down. Okay? For it can maintain the heat for some good time. Hmm?
Eh.
So that's why they use it for ice. And then other properties are there of plastics. Did we look at them? Properties of plastics. We looked at them. Hmm? We looked at properties of plastics, and we looked at mostly what is responsible and why they choose plastics, not any other substance. We looked at ceramics, why they use ceramics for making pots. Looked at glass, why they use glass. So some of those reasons you must know. At this temperature now, they are saying ice. It means if you use a plastic cup, the heat in the ice is not going to be loose. It's not going to be lost at a faster rate. Okay?
Yeah.
Okay, good.
Yes.
Now, boiling points. Boiling points. They are saying 3 unknown liquids ABC of any type. You can pick water, ethanol, and any other. Then anhydrous copper 2 sulfate. Boiling water over flame, thermometer, anhydrous cobalt 2 pepper. Now, in chemistry, copper is a metal. A sulfate is a radical. We shall also look at radicals. This is a radical. This is an element. So if you mix the two, they are giving us what we call a compound. The compound is called copper 2 sulfate. Now, when you use the anhydrous one, it has no element of water. When this water liquid is boiling, when the liquid is boiling, if you put anhydrous copper 2 sulfate, that is white, it will turn to blue. That means it has attained water. Cobalt 2 chloride is also used for testing water. So if you want to test water in the lab, ask for the anhydrous copper 2 sulfate or anhydrous cobalt 2 chloride pepper. Okay? So what you do, but this experiment needed to be done. Label your test tubes, 2 of them A and another one B, and at last 2 C. Now here is an example spirit. Do we know spirit? This one they use after trimming, they put on the head. So when you get that spirit and put on the hand, you try to relate the feelings you get with what happens to these elements around here. Okay? Try to put it on water and you get me the feelings, how you feel. Okay, so we are saying we shall get spirit, that one we shall get, and then we try to put it all power on the hand. Power on the hand. That is our assignment we have. I will not give you the whatever, but I want the observations you note. Okay? Observations.
Yes.
Okay.
From what you have got there, and then we shall get the comparison with this. So after knowing this, we want to look at all these are experiments you are supposed to do, but when you come to school, they will show you how those things behave. Now, you see this table, A, B, C, D, E, F. We have looked at one element
H.
has a pure substance which cannot be split into simpler by any chemical means. In the table, do we see elements somewhere?
Mm.
Hmm?
Mm.
Which of these in the table, A, B, C, D, E, F, G up to I, shows or gives you a brief definition of the word element? Hmm?
Table.
Which one?
H.
H. Why H? Why? What has made you say H?
And it's because an element has pure substance, cannot be split
Hmm.
by any chemical means.
Okay, that's a good attempt. Who else said H?
Because it has the same type or kind of atoms or molecules.
That's a good observation. Who else has seen? Huh?
A.
Yes? It is? Hey, where are the girls? Elise?
B.
It is B. Why?
Because they are pure and can't be split by any other substance.
Thank you for the trial. Ruth?
Yes?
Which one of these shows an element?
I think it's
Hmm?
H.
It is H. You're also in the same category of H. Maybe you have a different reason apart from the other two. Which one is yours?
Mine is the same reason.
Which reason is that?
They are pure and they can't be split
Okay.
into simpler substances.
Okay. That's a good observation also. Who else has not talked from here?
Rebecca.
Rebecca. Rebecca, where are you? Rebecca.
I'm here.
Very good.
Yes.
Which one represents an element from our table? Hmm? Yes?
H.
It is H. You're also saying H. Now, let's reason it out. Let's reason it out. You look at A. A has two things. One is gray in color, another one is in blue, isn't it? Hmm?
Yeah.
Let's make the same observation here. This is blue, blue. This is blue, blue, and then this is blue, and then this is deep blue. We are seeing some deep blue colors here. Then here we have this, but they are together in the same box. They're in the same box. We have this, 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 all of them. So these are different things. These are different. These are different. These ones are different. These ones are also different, but combined together. These ones are 1, 2, 3, 4. Are they combined?
No.
No. These ones are combined. You see them 2, 3, others are 4. Now this one is.
No.
Still using it. Now these ones are they not combined?
They are combined.
They are combined. I think they are 3, 3 in a small row like this. They are combined together. Now this one are also combined. So in our definition is a pure substance which cannot be split into simpler substances by any chemical means. A substance which cannot be split into simpler substances by any chemical means. If you look at this, these are different things combined together. Can't you split this? If you bring any chemical here, can't this one break off from this?
It can.
It can. If you bring a chemical here, it will also break off this from this. Therefore, this one can be broken. It spoils the name and element, isn't it?
Yes.
Yes.
Give me a clear one. Which one of those is an element?
Yeah, F.
F. Thank you very much. So F gives us a definition of the word element.
Element.
Okay? Because however much you split this, it will still remain rotating the same way it is. But this one can be broken easily. The same thing to this, the same thing to all this. So that is what we have there. So we have F as an element. F. Not F, but okay, it is F. Now, here they are telling us elements and compounds. Now, let's look at the way elements combine themselves to give us what we call a compound. Substances are classified into two mixtures. Someone is playing. Someone is there. Okay. I think now the ground is leveled. Substances are classified into two. One, mixtures and pure substances. We can classify pure substances into two. We can call them elements and
Compounds.
compounds. Those are pure elements, the way they exist, pure substances. They can either exist as elements or compounds. A group called compounds contains substances like water, sugar, salt. Sugar, a group of compounds contains substances like water, sugar, salt. These ones are called pure. The group of elements containing substances like metals, copper, iron, and the other gases. These are also another way. These are, so now, which one of the two is pure? Which one of these two is a pure element, and then which one is a compound? Okay, which one of these is an element and which one is a compound? They are telling us that a group called the compounds contains substances like water. It has sugar, it has salt. Salt is made up of what and what? Yes, common salt we use at home. It's made up of what and what? Who knows? The common salt we use at home? So those people who see salt at home, you just see it there, you don't know its name chemically. Eh?
I think salt also contains sodium.
It contains what?
Sodium.
That's the first element, sodium. What is the other element? The other element is chlorine. Okay? So
Chloride.
So salt is called sodium chloride. So this is a name called sodium chloride. We are going to look at the way these compounds come about and how you form them. Is it clear? In our next, that is tomorrow, by the way. Tomorrow, we shall see how these things are formed. We have about 8 minutes to finish, so we must make sure that we know. Now, water. Water is what and what? Water is H2O. Okay? Water is H2O. This is the chemical formula of water. So you see that in salt, our so-called salt, we have sodium and
All right.
Chloride. These are two elements combined together, isn't it?
Yes.
We even in water we have two elements. We have hydrogen and what?
Oxygen.
Oxygen. These are two elements. So now, if they are telling us all these substances are called compounds, Now, according to who? To Ruth, what is a compound?
Compound.
Please, let's listen.
Most pure substances that we use every day.
Most pure substance that we use every day. Thank you for the trial. Joshua, I want define according to what I've given you here, that sodium is here, chlorine is here. Those are two substances mixed together, or they are combined together. I don't know which kind of means they have used for combining it, but they are there together. So give me a definition of the word compound.
I try. I think a compound is a substance that contains more than one element.
Thank you for the, it is just, you're about to finish it. That is the exact words they use, but someone can continue.
A compound is a mixture of two elements.
What is combining them together? Yes, Ruth.
So can I try this?
Yes.
Compound are pure substances, but they can be broken down chemically into simpler substances.
Thank you very much. That is the way we define a compound. So let me give you a definition of a real compound. A compound is a substance. That's a compound. A compound is a substance. It can either be pure or impure. It's a substance which consists of two or more elements, chemically combined together. That's the definition of the word compound. So when you notice this, that a compound is a substance which consists of two or more elements chemically combined together. Two or more elements chemically combined together. If that word chemical is not there, then there is nothing combining the two. So what combines them is that chemical bond they have in between them. Is the one that combines them together. Like sodium and chlorine gives us sodium chloride. Have you got the definition well?
Yes.
Now, if I get sodium chloride and water, I mix them up, sodium chloride and water, I will get the word a mixture. I get sodium chloride, I get it together, I get the word a mixture. If I get sand or any other metal like sulfur, I put it in iron, I will get iron sulfide. If I get anything, I put it anywhere, I get a mixture. Give me a definition of a mixture. Yes.
A mixture is a combination of two or more elements.
Two or more elements. Two or more elements. Is it elements or this time a compound?
Compound.
Compound.
Compound. Two or more compounds.
Compound.
Now, do you mix them chemically or physically?
Physically.
Physically. physically. So a mixture is a substance which contains two or more compounds, but these ones are physically combined together. Physically combined together. I get my salt, I pour in water. I'm forming what is called a mixture. Okay? I'm forming what's called a mixture. That mixture has sodium, chloride, and water together. Okay? Is it fine?
Yeah.
So you know the
Yeah.
difference between an element, a compound, and a mixture. Element, compound, and a mixture. Have we known the difference? Yes?
Yes.
Yeah.
Okay, if we have known what they are, somebody give me the definition of this. A is what? Is it a mixture? Classify them according to either elements, compounds, and mixtures. A is what? Yes? Unmute, we have less than a minute to go. Unmute and we talk. A is what? Is it an element, a mixture, or a compound? A.
A mixture.
According to the definition, A is?
A mix.
A is a mixture. Huh? You note those whatever as well. A is a mixture.
A compound.
We have two elements combined together chemically. We have A is a
A is a compound.
compound. Thank you very much. B. What is B? B is? Hey, people have stopped talking. What has happened? Yes. Ruth, B is what? Ruth, B is? Rebecca. Rebecca. B is a mixture, isn't it?